Welcome to the second video. In the last video we ended with this, right? So a whole bunch of bar charts, and we used the data from JSON, put that into animation nodes, created the bar charts, created a whole lot of labels in this case. And in this video we're gonna take a different data set and create a different type of chart. We're gonna create a line chart with a curve. Okay, so I'm not gonna use this tree, just gonna start from scratch. I will keep this file here now. Now let's get data. Like I said, we're gonna use a different data. And I have this link for you, which is blockchain.com/chart/market-price. And this is basically the Bitcoin price chart that you can download here as in JSON format. Perfect. So how about we just do 1 year? That looks good. Looks interesting. 1 year, 7-day average. Export this as JSON tutorial2.json. Okay. And now we're reading this data in here. Let's close this and let's execute. How about we go print J here, just so we see what it looks like inside. And then comment this, save, and execute. Oh, okay, this looks like this. Okay. So what do we have here? We have a JSON object, status okay, name, market price, blah, 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 blah. And then we have values here. This is what we're interested in. Okay, so the data is going to be values. But we can already see a tiny little problem here. Yes, values is an array, which would map to a list, just like in the last video. But inside, we don't have lists. We have JSON objects. Now this becomes a bit tricky inside of animation nodes, because I tried this and animation nodes doesn't know what to do with these kinds of objects. So instead of just simply parsing it and taking the values property of this JSON object, we're gonna do a little bit more in Python here. Okay? Don't worry, it's really not complicated. Okay, so we know we want the values, right? And let's just say we assign this to a new variable and call it v for values. So now we know that this is a list of JSON objects looking at our JSON data down here. Okay. Now we're going to create a loop. So for object in v, oops, for o in v, I want to do something. I want to get this y value, maybe even the x value. Okay, let's do that. Let's get the x value. So our data array that we want to give to animation nodes starts off being empty. And then in here we can go data.append. So we're going to append a new entry onto this array. And what do we want? Well, how about we want object x and object y, like this. But all of this has to be in a list. That's the whole point of my for loop here. I'm taking a JSON object with the curly braces here that has x and y, and I'm putting the x and y into a new list. Let me zoom in here a little. Putting it into a new list where the first element is the x, the second element is the y value. So now how about print data here? Maybe take this out, save, and execute. And what do we have? We have a list of lists. Perfect. And it's already named data, so the same script that we had in the last video will still work. Or would still work. I kind of deleted the entire thing, right? So let's add a script node. Which script do we want to execute? My script, this thing over here. W create invoke node, and this is what we're invoking. The new output is again going to be a generic list of lists, and we have to name it data here because that's what we named it here. Okay, so just like in the last video, we now have a invoke subprogram node, and it gets the data, a list of lists, from JSON, and we can do stuff with it now. So in this tutorial, we're going to use that data and create a spline or curve. Again, we're going to use a loop. So shift a subprogram loop. And this loop needs to take in the generic list. I'm going to call it data again. And then create a spline. So it's going to output a list of vectors. And outside of the loop, we're going to create a spline from that. Awesome. Let's do that. Okay. My loop. We need to create a vector. So combine a vector. We want to change the C value according to this entry here. And just like before, we're going to go list, get element. Change this get list element over to be of generic list type, so we can plug it in here. The element that comes out here needs to be converted to a float, and we convert this float and put it in the C. Conversion failed, and I'm gonna take index 1 from my invoke, and I'm gonna plug this in here. So I need to invoke, whoopsie, I have to invoke this script and plug that in here so that each entry ends up here. Now we have a vector that is changing its C location according to the value from here, like index 1 is this entry. This one, by the way, is a timestamp, and we can use that too. But now we have the C value here. We need to definitely put in a number math node here and divide this by a lot. Let's do 1,000. And then we get a list of vectors. We have to output this list of vectors out of our loop. So we click this, we click new generator. The output of this loop is supposed to be a vector list consisting of all of these vectors. Now our subprogram has an output here, and we can use that to create a curve. So shift A spline create from points. This is good because we have points. We're going to create a Bezier spline. Now we have to do something with this spline data. We need an object output. Plug the spline in here, create a new object called target, enable the spline, and what do we get? Can we already see something? Oh, what is this? Yes, we can see something. Okay. How about we also enable bevel depth and turn it up a little so we can actually see something up here. Now this looks weird. This can't be right. What is going on? How about we create a shift A viewer, loop viewer, and let's see what we get here. So plug this in here, create a new loop viewer to the right, and then execute the node tree. So here we get the values. This looks correct. These are the values of the Bitcoin price in dollars. So $11,000. So how about we divide this by 10,000. Ah, you know what? We're putting them all at the X location of 0. Wow, that's that's no good. Okay, let me duplicate this math node. Take the index here, which is going to give me like 0, 1, 2, 3, 4, 5. then we divide that by, I don't know, how many entries do we have? How many entries do we have? Let's shift a viewer here and see this. Oh, 365 entries. Because we get one entry per day, and we said we wanted to look at the last year when we exported the data. Okay, so it's 365. Okay, how about we divide this by 10? Okay, it's still gonna be quite wide, but we can plug in the X here, and then we get the chart. Cool. Let's look at it from front view. A little bit more room. This is quite long here. Okay, so let's maybe just divide by 5. Divide by 20. So we get this in a little on the X. Now on the Y, we don't really see much movement. So maybe dividing it by 5,000 instead. 3,000. Okay, this looks like a cool Bitcoin price chart. Awesome. And we have all the data points in there. And this is a curve now. So we actually have a spline. We can change the bevel depth here. We could even plug in a spline smooth Bezier. Does that help? So this is the chart. And of course now we can go in. We could create like an X-axis and a Y-axis and some labels and whatever. Okay, now just one last thing. Because we do have the timestamps in here, right? So this is a timestamp. How about we take this timestamp in Python and do something with it? So, like I said, this is a bit more, whoopsie, I don't want this. This is a bit more advanced and it's a bit more Python scripting in here, but I'm sure you can still follow along. It's really not complicated at all. So how about we create a new variable, D for date, and then we convert that X value, this guy here, somehow into a date, and then format it, and then have a text that we can use in animation nodes. Well, that sounds complicated, but it's really not. There's a library here in Python that you can use. It's the datetime library, and you just go datetime.datetime from timestamp, and we take that OX value here. Okay, and then so now we have a data type which is a datetime, and now we can format it. And to format that, it's just str f time. Okay, so string format time, and then we can enter the format that we want here. So the year %y, then we want the month, and then of course we also want the day. We know that we have one data point per day. So this should be very nice. And then instead of putting the X value in here, we just use that D, which is now a string. Let's see if this works. Save the script and execute it. It said Python script failed. Oh, name datetime is not defined. Of course, in order to use this datetime library, we have to import it up here. And then when I execute it, we get arrays. The first element is a string with the date. Second value is the actual value. Okay. Awesome, awesome. So, very similar to the last video, basically exactly the same thing. We need some text objects. So, first of all, I'm going to go to this scene collection, shift a text. Okay, we don't need to do anything with it, we just need the object. So I hide it, shift a object instancer. We want the text. How many instances do we want? Well, this many. Okay, we enable copy full object in deep, so we get real individual objects and no mesh or other data copied. So now we can plug that into our subprogram. So let's move this over here, just so that we can plug those objects into our subprogram. The subprogram is down here. We need a new iterator object list. Call it labels. We plug our labels in there so we can do something with them. And what do? We're going to shift a object transform output XYZ, and we are going to transform the text to a new location. The location's X value should be the same as here. You know what? I'm gonna combine. Whoops. This has to be connected here. Okay. So the X value is going to be this guy, and the C value is going to be 0. Okay. Now we also need the texts, so we need to get a list item from our generic list. Switch this over to a text list. Yeah, this converts in front. No, we're gonna switch this over. We're gonna leave that as a generic list, so we can put this guy in here. And we're gonna convert afterwards to text. Take this guy. Now we have to assign the text to this text object, just like before. Object, no, where is it? Text. Object output. Plug that in between here. Assign this text to this object, then place the object. So what do we look like? Look like nothing, actually. Okay, I fixed it. I had a typo in here. I somehow deleted a letter, but we have a bunch of text objects here. Of course, they are huge, as you can see. So we're gonna have to scale those down. Scale down quite a bit. And of course also rotate C 90 degrees. And here we have values. Oh, we have values because we want to take index 0. Now we have the dates. All right. And this is how we can add the dates here. Now, what if we wanted the dates to show up on top here? Of course, that's just a matter of rotating. Maybe rotate on the X. X is making us, oh, Y 90. How about that? Or minus 90. It's even better. Okay, so we have those. Then let's take that down even further. So we have tiny labels. But 365 of them all the way over here. And now I also want to place them up here. Okay, so transform location. The C axis should be the same value as this one. So now they're up here. And I have to shift them a little bit. So I just add another vector math in here. And then I can shift the C up ever so slightly. Cool, this looks interesting. So we have the values, we have a graph, and we have the dates up here. If we don't want the dates, of course we could use the values. Now, of course, again, materials, animations. How can we animate this? Let's check this out really quickly, just so we have the timeline down here. We have, let's do 100 frames. Okay. You know that the chart is inside of a curve, and the curve is called target here. We created it with this node in animation nodes here, and we can go into the geometry of that curve, and we can animate this bevel start end. Okay, now it's your turn. Here's your homework. With everything that we've looked at in these 2 videos, you too should be able to create this kind of 3D heat map. You can use the same data as I did here from Blender Open Data, or find your own interesting 2-dimensional dataset with an X and a Y. Please tag me when you post your creations on Insta or Twitter, and let me know in the comments below if you would like to see another video where I show you how I made my heat map. Please subscribe to the channel if you are interested in more Blender tutorials. Thank you for watching. Crispy out.